The talk we will have right now is from Felicitus, and he will say us something about solar-powered autonomous routers. Give him a warm applause, please.
Okay, thank you very much. Yeah, thanks for coming here. Many people. I hope I don't get too nervous, but yeah, let's get started. Yeah, my name is Felicitus, and I'm talking about solar-powered autonomous routers. And one thing I might explain first is I'm not at the autonomous router stage yet. So what I've done so far is build a router, which is actually an open VRT device sitting in my garage, and just publishing data to the internet. It's not routing at all right now, but of course it's an open VRT device, so you can actually do routing with it. So let's have a look at the solar system types. There are two main types, the grid-connected ones and the standalone ones. I'm using the abbreviation PV in my talk, which is short for photovoltaic systems, but PV is shorter, so whenever you encounter the PV, you know it's photovoltaic. Okay, so the grid-connected PVs is what you see everywhere. They are in houses, they are connected to grid, so if there's no sun, you still get power. And yeah, if you gain so much energy from your solar system, it will be fed back into the grid, so you have no losses there. Yeah, that's a typical solar system. It's right on the other side of the street I'm living in, and yeah, they install like 1 kilowatt peak or something like that. So if you have solar panels, they are usually measured in kilowatt peaks or watt peaks. That's because the solar panels are have a rating, which is the nominal output value. If you have like 250 watts peak, it means that it's at full sunlight, and then of course it will decrease as the sun goes away. But we'll get to that later on. These are standalone PVs. Yeah, it's a little bit hard to see due to sun, but it's a parking machine which can operate completely without connected to any mains, to any grid. They have a battery inside, and they have a little solar panel which stores the energy. So that's the type of PV system we are talking about here. And yeah, that's your typical standalone PV setup, where you have your solar module, you have your lead acid battery, you have your charge controller, and you have your load represented by the light bulb. And that's all you basically need for a solar system, which you want to operate 24 hours and 365 days a year. The real challenge is to design the system that you don't need to recharge it at any point in your operation. And yeah, we have a few considerations to do that. The most important thing you need to consider is the load. So you cannot say, okay, I buy a panel and I buy a battery, and then I can hook everything I want. So you actually need to know which device you actually want to power with. And that's the base of your calculations to find out the correct battery size and the correct panel size. So I mentioned earlier, the most important factor is the watts peak. So you can get like small solar panels with 50 watts, 20 watts, 100 watts, and 250 watts. And they are all measured in watts peak. And its watts peak is measured with an irradiance of 1000 watt per square meter. It's a standardized value, so you can actually compare solar panels from one manufacturer to another, or from one solar panels type to another, because there are quite some. There is polycrystalline, there's monocrystalline, and so on. But if you have your watt peaks, you know how to compare it. So yeah, the maximum output power could be higher if you have really bright sun. Yeah, but don't count on it. And your typical energy harvesting will be much less than the watt peaks. So I have at home I have a 20-watt panel, and yeah, I typically get yeah, maybe 10 watts on a bright sunny day, and maybe 2 watts or 1 watt out of it. Yeah, when it's raining. So it depends, and it's in summer I expect it to be much less in winter. Um, yeah, that's for the like 5 to 10% in summer, probably 1 to 2% in winter. So it varies actually a bit with your location. So if you're in Italy, maybe you will get much more energy out of your cell with the same cell than you might do in Great Britain. A little bit thing about batteries. There has been quite some discussion with me prior the talk. This is not the first talk I'm giving. People are saying, "Hey, can I use my lipo batteries or something else?" And I've researched it a little bit, and I always say, "Okay, take the lead acid type battery. That's the battery you want, and you have no problems with that, or very little problems. They are easy to charge. They require almost no maintenance." They are perfect for like hot or cold temperatures. They don't care. The only problem is that if you have a lead acid battery, the capacity will go down. So it's minus 10 degrees, only 70%, or minus 20 degrees, I think it's 50% or something. That's something you need to consider if you're maybe living in Russia or in Siberia, where it's really cold. So you might need a bigger battery. But for our calculations, I will focus on yeah, the typical Central European weather. Yeah. What you can do is you can take a car battery. They are pretty cheap compared to real solar batteries. But yeah, if you can get a real sealed lead acid battery, it's much better because you can the sealed lead acid battery, you can place it in any position, and the car batteries always need to stand up upright. So that's one thing you need maybe to consider. The most important parameters are the amp hours and the voltage. And the voltage for most lead acid batteries is about 12 volts. That's the nominal value. If they are charged, they are like 13.9 or 14 volts. And if you discharge them, they will actually go down to like 10 or 9.5 volt, depending on the type. So if you have questions about your lead acid battery, always consult your datasheet. It's the most important piece of information you can get for your battery because they are so different and so many manufacturers that you really want to look in the datasheet. In this talk, I will take the VRT45G. That's a router you should everyone knows it, or most people knows it. And yeah, it's rated at 12 volts and 1 amps, which makes 12 watts of power usage. And yeah, I have one of these devices and I measured it, and it's about 8 watts average power usage. And so we can just multiply that with our 24 hours, and we get 192 watt hours per day. So that's our value we need to concentrate on. That's the basis of all calculations. And let's look at the batteries. Of course, half the day is darkness, or about half of the day. And so we need to compensate for 95 watt hours we lose at night because there is obviously no sun. Oh, sorry. So the battery needs to be at least 8 amp hours so we can cover up the night. And that's not really a calculation, it's an estimation, but I will get back to that later. You cannot charge your battery full every day because there are rainy days, there are really dark days. Maybe in Africa, where you have really much sun, you can do it, but it's not impossible. It's really impossible in Europe. So yeah, that's what you need to consider. And we have a reduced capacity and light in winter. So it's not only the missing light, but it's also the battery capacity going down. So we also need to compensate for that. And as you will see in a few minutes, it's really getting nasty to estimate the correct battery size and the solar panel size, because you think it's only a router, but which power could it draw? But it's really lots of power, which we need to harvest through the solar cell. So about the solar cell considerations, we have a oh sorry, I need to think it through. Yeah, we have like, that's an estimation I made of the 1% of the watt peak. So if you take like a 250 watt peak cell, I expect that it will be only delivering 2.5 watts in winter. So that's what I based the calculation on, or the estimation. And I said, okay, I have the 8 watts peak for my router, and I multiplied by 100, means that I would need a 800 watt solar panel. And an 800 watt solar panel is like this big and this high. So yeah, it sounds pretty much. So let's back to the battery calculations and or the estimation. And what you also need to consider, there are days where you have really bright sun. Like the past few days we had, there was a little bit of rain, but it was mainly sunny. So I expect that the battery we are using in our imaginary system would be like full on the first day. And it can't get any fuller because it's already full. So we are losing power by the sun. We cannot store. And then there are days we don't have any solar power at all, like on rainy days or on dark days in the winter. So the battery needs to cope up for that. And yeah, it's really hard to calculate the actual setup. So we need to look at a tool which I found like half a year ago, and it's called PVGIS. It's unfortunately only available for Europe and Africa. It's developed by that Joint Research Center of the European Union. And yeah, you can, it's a screenshot. I don't know if you can see it because of the light. You can actually go to your location and do estimations on your plant setup. So you put in, there is the, this is the estimated PV, sorry, this is the, oh man, I can't read it. Entry peak PV power is standing there. Okay, this is my 800 watts peak. This is my 80 amp hour battery. This is my 12 volts, and I click on calculate, and oops. This is the result calculations for my location, and it says this is the month from January to December. This is the, I think, sorry, I can't read it really. Oh yeah, okay, this is the estimated daily power consumption. This is the amount, the percentage of days where the battery is full, and this is the percentage of days the battery is empty. So you can hardly see that the battery is full, like from yeah, from March to October, the battery is full every day. And yeah, same goes for battery empty. There's a zero in all of the columns in that month period. The battery won't get empty in summer with that size. But if you look at January, the battery is full only 67% of the days, and it's empty at 2% of all days. So that means this is quite a huge setup with an 800 watts peak panel and an 80 amp hour battery, which is really huge. It's huger than usually car has, and we still can't get enough power to operate the router in January. So you might ask, okay, sorry, I have put up 2 rules of thumb, so you can quickly estimate your the solar panel size. You just multiply your power of the circuit by 100, and you get your watts peak. And the same goes for the battery. Multiply your circuit power by 10, and you get your battery size. So in this case, these are the 800 watt peaks and the 80 amp hours. And the thing to do here is not to make your solar panels large, but to shrink your power consumption. That's the basic thing you need to do if you really want to go down in size and down in costs. So I'm using a router which is based on the AR9331 chipsets, but the 9331 is also nice, and they have about half to a watt power. So it's about a tenth of the size we need for the VRT device, the VRT 54TL. What you can also do is, if you can't reduce your device power consumption, you can also turn it off when it's not required. But I believe that this is the wrong approach. So if you really, sorry, questions? Or you can try to modify the device, yes. But that's not always an option and not always working as you might expect. So what can we do also to reduce or to get more efficiency? The regular charge controllers you can get on eBay for like 10 bucks aren't maximum power point tracking ones. They are using PWM to charge the battery. And yeah, if you can get a maximum power point tracking charge controller, get one, because they can get maybe 10 to 25% more energy out of your cell because they are using a step-down converter instead of PWM. So yeah, if you can afford one, they are a little bit more expensive, like 40 bucks or so, but it's worth the investment. This is actually my setup at home. I know it's a little bit hard to see due to sun, but this is a Carambola 1 board, which is my router actually. This is the charge controller, this is my battery, and this is a monitoring board I've built to actually read the power consumption and publish it to the web. So it basically measures amps and volts, both of the cell and the battery, and transmits it via a serial device to the router, and I push it onto the web from there. So that's my setup at home. This is a 20-watt solar panel on the right-hand side, which is not sufficient for my purpose. It works for like I think 3 months with some minor outages. In my setup, I would need a 100-watt panel. So I will get really problems when it's going like to October, November. Yeah, the router will pretty often be not available. But right now it's okay, and I will optimize the design a little bit, use a more efficient router. But that's what's actually in my garage, in my garden, working for 3 months now with minor outages and yeah, collecting data. The next thing is what I wanted to do is to visualize the data. So I want to know, okay, how is sun affecting my solar panel, and how long is the uptime of my router, and how much power does it draw, what is the temperature, and all these things. Yeah, I started actually with Cosm, and which is now Xively. You might know it. It's some kind of Internet of Things graphing online service. That's what I started out with, but I had a real problem with them because I couldn't get my data back. So I always published my data to them, but I couldn't read it out. So I couldn't do any statistics on it. I think they have it now, but I'm not really sure due to the progression to Xively. Yeah, I tried OpenSense for like 2 or 3 days, which is another software as a service provider. but yeah, it did work kind of, but I couldn't do the reporting I wanted. So I looked further and I found Graphit, which is a very nice round-robin database software. Here's a little screenshot of it. Yeah, it's again hard to see. I'm sorry, but it's a graphing window here, and these are my metrics for which I'm collecting right now. I collect the current of the batteries, the cell current. I actually calculate the amount of watt hours I've earned for the day, and which I've spent, and I can actually do a graph where I have the zero line and have the positive where I earned more power than I used, and the negative side where I spent more power than I've earned. So yeah, that's actually available online. I've put the links on later. So if you have interest in it, you can actually play around a little bit with it and see yeah, what kind of statistics this tool supports. Yeah, I think it was pretty quick, so we have probably plenty of time for questions and answers. Okay, thank you. So we already have a question here.
I saw you doing all your calculations based on you
Yep.
need an 800 watt panel, but then at the end you just need a you were using a
Yeah,
100 watt
sorry,
panel.
it was a bit confusing. I based the calculations on the VRT 54G because everybody knows it, and I'm actually using another router.
So it's 80% less. 80% or 90% less panel.
Yes. So the VRT 55G takes about 8 amps. 8 watts, and the router I'm using now is only using 1 watt.
Can you tell something about power consumption for Wi-Fi cards or 3G and turning that on?
No, I haven't measured them. So yeah, you can or you should actually do your measurements before you buy any solar panel or any battery. So measure the device, measure it under load, and see how much watts does it really draw. So you are really on the safe side. Any more questions?
Yeah. Why are you fixed on solar panels? Why do you thought about wind?
I do have thought about winds, but I've no experience with wind, and I think it's also a little bit more mechanically problematic for me, because it's pretty much simple for me. I'm not a hardware guy so much, so yeah, I bought a solar panel and went from there. So yeah, you can do it, but this talk was just about solar panels. So if you're maybe you put up maybe on the Congress a talk about wind energy, it would be very interesting.
Okay. You do not mention the optimal angle of your solar panel.
Oh yeah,
that's an
yeah, I forgot to
important
talk-
thing.
Yeah,
You should
that-
aim. Yeah.
Right, that's a very important thing, but it's not that important that you might think. No, actually, if you have your solar panel, let's say this is my solar panel, and the sun is shining from that direction, you only lose like 10% of efficiency.